10.7 is subtracting polynomials. So subtracting polynomials. And the nice part is it's really just one additional step to what you were doing yesterday. Although we're also going to cover like additive inverses, but that's just a little tiny part. So the key is really just this. This is kind of like the what's the one extra step if you mastered 10.6, the adding polynomials. The thing you do before really adding, the thing that changes the subtraction problem to an addition problem, is you distribute the negative or the subtraction. Because the subtraction is really kind of like a negative, but sometimes it'll just be a negative, to each term. Then combine like terms. Because that's what we found yesterday. Addition was really just a matter of combining like terms. That if you had an x squared in each one, you had to put all the x squareds together, put all the x to the first together, and all the constants together. Subtraction, we just have one additional step, and that's distributing the negative. So what do I mean by that? So example 1, I'm going to say this is my problem. So I have in parentheses 13x to the third plus 10x minus 11. So end my parentheses, subtract, and then I have another polynomial in parentheses. 6x to the third minus 9x plus 2. I'd leave it how I have it here in green. I'm going to make a change to it and kind of bring up what we did yesterday. Yesterday, we had a problem that looked like this, so I wouldn't do this stuff here with red. We had this problem here, and it was an addition problem, and I said if we could put a number right there, the number that we could put there would be a 1. And I said that you can kind of look at it as though it's a plus 1 times this, and if you distributed it, it would just give you the plus 6x to the third, and then a minus 9x, and then a plus 2. Yes? So it's kind of doing that somewhat because that's really what we're doing today. That we don't have a plus there, we have a minus, but if you had to pick a number to put right there, it's kind of like having a little minus 1, right? And so you could, if you wanted to, view it that way, that really it's like I have this minus 1. What really ends up needing to happen is we really need to subtract each one of these three terms here in the second polynomial. And one way to do that is to say, okay, it's kind of like I have a negative 1 times this 6x to the third. Negative 1 times a positive 6 gives me negative 6, so it's minus 6x to the third. Negative 1 times a minus 9x gives me a positive, so it becomes a plus 9x. And negative 1 times a positive 2 becomes a negative 2. So essentially, really what's happening is you're just changing the sign of all of the terms in the second polynomial. And yep. Well, it started out though as a plus right there, a positive 6x. So we have to make it a minus. So you could view it as though you're distributing a negative 1. I think mathematically that's more accurate. But if you want to just tell yourself, it just changes the sign and everything after the minus, that's true. You know that would work. But now once we're here at this line, it's the exact same thing as yesterday. So we say, okay, I have x to the thirds. That's my largest exponent. So here I have 13 of them. I want to take away 6 of them, which leaves me how many x to the thirds? 7? X to the thirds? So I have the 13, take away 6, gives me 7. And then my next, I have a positive 10x. I want to add 9x to it. So I end up with how many x's? 19. Perfect. So positive 19, so plus 19x. And then last but not least, I have a negative 11. Take away 2 gets me down to negative 13. So final answer ends up being just that polynomial there. So other than distributing that 1, it's really the same type of thing as yesterday once you get to that line. Feeling okay with example 1? Yeah. Going to come back to this in a minute. Example 2 is a different type of question. Example 2, and for this they call it an additive inverse. So find the additive inverse of, and my number is 5x to the fourth minus 2x to the third plus x minus 9. So we've been talking about inverses. I've kind of been intentional about using that word this year. We said like the inverse of addition is going to be what undoes addition. So the inverse of addition is subtraction. The inverse of division is multiplication. So additive inverse is going to be saying, all right, I have this polynomial. What could I add to that polynomial to totally cancel it out? So what could you add to just this 5x to the fourth to make all the x to the fourths drop out? Or to get down to 0, Drew, you could subtract 5x to the fourth. If you have a positive, you could subtract 5. If you have positive 5x to the fourth, you could subtract 5 and you'd be down to 0. So the inverse of that 5x to the fourth is going to be a negative 5x to the fourth. If you wanted to cancel out a negative 2x to the third, you would you add 2x to the third. If you want to cancel out a positive x, you subtract an x. So you have positive 1s and you do the opposite. And then you had the negative 9, so you need to add 9. So then, well, we're done because you can't combine like terms there at all. So the additive inverse, realistically, what do you just do to your original? You change every positive, negative. So if it starts out a positive, you make it negative. Starts out negative, you make it positive. To find the additive inverse of a polynomial, you just flip all the signs. Is that fair? So additive inverse, and you could, if you wanted to, write yourself a little note. So additive inverse, what do you want to say? Flip signs? Change signs? Flip. Maybe flip positive / negative or something like that. Flip the signs. Just do the opposite of every sign. Example 3. We okay to jump to the third example? Example 3 is going to be really kind of the same thing as the one before. So example 3, I'm going to have, well, we'll say x squared. So x squared minus 8x plus 4. So that's my first polynomial. And I want to subtract, in parentheses, 3x to the third plus 9x squared minus 5x minus 2. Have it all copied? So the way we talked about doing this before, you could look at this as, all right, we have a negative 1 here, and we distribute the negative 1 to each one of these clumps. And then doing that really just changes it into an addition problem. So x squared minus 8x plus 4. And then where I had the plus or a positive 3x to the third, that becomes a minus 3x to the third. So I have a negative 1 times a positive 3. My plus 9x squared becomes a minus 9x squared. Negative 1 times positive 9 gives me the negative. My minus 5x becomes plus 5x, because negative 1 times negative 5. And then my minus 2 becomes a plus 2, because a negative 1 times negative 2 gives you a positive 2. All right, now we can go through and find combining like terms. All right, so my highest exponent is x to the third. So I have that right there. Make sure you keep the sign with it, so minus 3x to the third. And next I have x squared, so I have this and that. This tripped some people up in my other class. How many x squareds do we have? Negative, how many? Nope, not 9, 8. Nothing like making you not want to guess when the teacher says, everybody else messed up. But the reason is, this here I have 1, right? Even though it's not written in, I have a positive 1, and then this is saying you go 9 to the left on your number line. So it takes you down to a negative 8. All right, so we have that. And then you could go for, well, not green. So I have negative 8x's plus 5 gives me minus 3x. And then last but not least, what do we say, plus 4 and a plus 2 for a total of plus 6. So final answer, that thing there. Agreed? Yay! This is where I probably should stop. There's a faster way, but the faster way tends to get people in trouble. So I'd maybe look at the faster way, and if you're going to try the faster way, try it on a couple of the homeworks and then check your answers, as opposed to waiting until the quiz and what was that faster way, and then do it there when the points really matter. But this way works. Changing the sign and all the things after the subtraction, or doing the negative 1, distributing that to the polynomial, that's kind of the safe way. Here's the exact same problem. Here's a little faster way, the way I do it when you guys aren't watching me. I do this. Okay. My biggest exponent is x to the third, right? So I have that one right there. Do I have any of those in my first polynomial? So you could kind of view it as though you have a 0x to the third. Well, 0x to the third minus 3x to the third gives me negative 3x to the third, right? And then, all right, I have how many x squareds right there? 1. So if I do 1x squared, kind of the minus 9x squared, so 1 minus 9 gives me negative 8x squared. Tracking with me so far? So it's just kind of like what's in the front minus what's in the second. Now here's where it gets a little bit dicey. If I have a negative 8x minus a negative 5x, that's going to give me, without looking at your last page, negative 8 minus negative 5 is negative 3. Because minus the negative 5 degree, that turns it into plus, subtracting a negative. So it's really negative 8x plus 5x, so minus 3x. And that's where I found people tend to make mistakes. And then the final one would be, we'll say, a positive 4 minus a negative 2 gives you a total of positive 6. And that right there, the colors I'm sure will be different, but should be the exact same answer as the one we had before. So that way works. It's a little bit faster because you're not rewriting it. But if you find you're making mistakes doing that, then go back to the old-fashioned way where, okay, I'm going to just flip the sign on everything in that second part. So plus 3 becomes minus 3, plus 9 becomes minus 9, minus 5 becomes plus 5, minus 2 plus 2.
Do they calculate on the quiz?